The reading speed of second grade students in a large city is approximately normal with a mean of 91 words per minute and a standard deviation of 10 words per minute. What is the probability that a randomly selected student will read more than 95 words per minute? Okay. So right now we're just looking at a normal problem from the previous chapter. So our mean is 91, our standard deviation is 10, and we're looking for the probability that x is greater than 95. Okay, so we're going to plug everything into StatCrunch. So our mean is 91, and our standard deviation is 10. We want the probability that x is greater than or equal to 95 and compute. So this is approximately 0.3446. So B, we want to know what is the probability that a random sample of 12 second grade students from the city results in a mean reading rate of more than 95 words per minute. So now we're talking about a random sample and we're looking at a mean reading rate of more than 95. So we're working with a sampling distribution of x bar, and we know that it is normal. Right? So if the population is normal, then that means this is also, the sampling distribution is also normal. Its mean is the same as the mean of the population, which is 91. And its standard deviation is sigma over the square root of n. So that's 10 divided by the square root of 12. Let's get an approximation. Again, we won't use that in StatCrunch, but just so we know what value we're looking at. So 10 divided by second x squared to give us the square root symbol. 12, close parenthesis, and enter. So 2.886751. So we decreased quite a bit in our standard deviation, so our distribution shape now is not as dispersed. So we're looking for the probability that x bar is greater than 95. Let's fix that greater than symbol. Okay, so greater than 95. Right, so let's use StatCrunch here. So I'm going to do 10 divided by SQRT, parenthesis 12 for our mean. For our standard deviation, and I don't need to change anything else and just hit compute. So in StatCrunch, our mean is 91 and our standard deviation is 10 divided by SQRT 12. We're looking for the probability that x is greater than or equal to 95. Right. Our answer here is 0.0829. So you can see that decreased our probability quite a bit. So now let's look at a random sample of 24 second grade students, and we want to know results in a mean reading rate of more than 95. Still the same probability, just a different sample size. So we want to see what effect that's going to have. Alright, so our sampling distribution is still normal because the population is normal. Otherwise, we wouldn't know because our sample size is too small, right? It's under 30. Our mean is still 91 of our sampling distribution. Our standard deviation is going to change because our our sample size changed. So we're dividing by the square root of 24 this time. Right, so we're going to do 10 divided by the square root of 24. So we're dividing by a larger number, so we should anticipate our standard deviation should get smaller. So 2.041241. Right? So we're looking at the probability that x bar is greater than 95. So StatCrunch, our mean is 91. Our standard deviation is 10 divided by SQRT of 24. And we're looking at the probability that x is greater than or equal to 95. Right? So we'll type that in. So we're going to change the square root here from 12 to 24. Right? An even smaller probability, right? And that's because our standard deviation is getting smaller, it's less dispersed, right? Now let's look at the next question. So we want to know what effect does increasing the sample size have? So we saw that it decreased our probability, right? So we know that these two are wrong, so we can eliminate B and C. Then we want to know, because what happens to our standard deviation? Well, what do we see about our standard deviation? We went from 10 to 2.8 to 2.0. So our standard deviation also decreases, right? So if our standard deviation decreases, that must mean that A is our possibility here. So one last question. So a teacher instituted a new reading program at the school. After 10 weeks, it was found that the mean reading rate of a random sample of 18, so still sampling distribution here, was 93.3 words per minute. What might we conclude, right? So we're going to try to see if the program's effective or not. And so we're looking at the probability that x bar is greater than or equal to 93.3 is what we're trying to find. And so our mean, still the same mean that we had before of 91. And let's fix that. That doesn't look too clean. So our mean here, right up here, is still the same mean that we had before, which is 91, and our standard deviation is sigma over the square root of n, so that's 10 divided by the square root of 18. 10 divided by the square root of 18, so 2.357023. So in StatCrunch, our mean is going to be 91, and our standard deviation will be 10 divided by SQRT 18 there. So let's punch that in here. So same mean. Standard deviation is 10 divided by the square root of 18. So I'm going to change the inside of this parentheses there, and we want it greater than or equal to 93.3. Right? So we get this is 1646. Right? And so it's not unusual, right? Since the probability of obtaining a result is, so we're going to fill in our blank. The new program is not abundantly more effective. So if it's unusual, then you can say that it's more effective here.